So we are now at 1030, and I would like to seek the permission of my chairman, Admiral Sunil Lanba, to commence today's proceedings. Permission, sir?
Yeah, please.
And Dr. Ramadass, are you ready, sir?
Yes, sir. I'm ready.
Okay, great. So good morning, ladies and gentlemen. It gives me singular pleasure and it provides a sense of honor to be able to welcome Dr. G.A Ramadass, the director of the National Institute of Ocean Technology, NIOT, which is headquartered in Chennai, in our midst. He is an extraordinarily busy man, and that's not surprising because he is extraordinary in every other respect as well. We have, for this eminent person's lectures, a series of genuinely eminent personalities, and I'm delighted to be able to add Dr. Ramadass to this list of luminaries who have enlightened the National Maritime Foundation and its well-wishers. I can see that Pankaj from CAS has joined us once again, so it's a very good morning to all of you. Many of you in the virtual audience have been supporters, well-wishers, and my own mentors and guides over the years, so this is as good a time as any for me to be able to reiterate my gratitude to you. It is also fitting for me to give you some short encapsulated idea about the towering personality that we have in the form of Dr. G.A Ramadass, who, as I said earlier, is the director of the National Institute of Technology, NIOT Chennai, which, as many of you know, is an autonomous body under the Ministry of Earth Sciences of the Government of India. Now, his research areas include deep sea technology, deep sea mining, underwater acoustics, and marine instruments. Presently, he is coordinating a project for the development of the Indian manned scientific submersible MATSYA 6000, which is intended to carry 3 scientists and/or engineers down to an oceanic depth of 6,000 meters, manned. This would be quite a remarkable feat, and I have no doubt that it will be achieved. And like all the rest of our countrymen, we will be on the sidelines cheering and applauding the huge effort that has been undertaken by the NIOT under the able leadership of Dr. Ramadass in this venture. In fact, since the very inception of the NIOT in November of 1993, Dr. Ramadass has been spearheading a variety of technology development projects. I think, I don't know whether all of you are aware that in 2010, he won the National Geoscience Award under the Exploration of Oil and Natural Gas category. And even more important, in 2017, he was the much deserving winner of the National Research Development Corporation NRDC Award for the year 2017. Now, the National Research Development Corporation Awards, or the NRDC Awards, are given over a large range of disciplines where Indian young people and more mature scientists and social scientists, that means science of all kinds, is recognized and are afforded for their innovation. To support their innovation, they are afforded awards which could range from, I think, about 1 lakh to 5 lakhs per person per award. So we have in Dr. Ramadass a winner of the NRDC award for the year 2017. He also led the NIOT team during the 34th Indian scientific expedition to Antarctica, and that was in, I think, in February and March of 2015, which is the summer expedition. And as some of you know, I can never stop crowing about the very fact that many years before that, I myself had the privilege of going as the expedition navigator and the South Pole navigator, or the South Pole team navigator in the fourth Indian scientific expedition to Antarctica. So it's a bit before Dr. Ramadass's time, but nevertheless, I have a bond of Antarctic visitors which actually transcends time. So I'm very pleased to be able to say that. In that particular 2015 expedition, the Polar Remotely Operated Vehicle, which was known as PROVE, which was developed indigenously at the NIOT, was indeed used for the exploration in the lake as well as the shelf area of Antarctica during that expedition. Dr. Ramadass obviously has a galaxy of academic qualifications. He is a doctorate from IIT Madras. He got his MSc from IIT Kharagpur, and he has handled, as I've already mentioned, numerous technology development programs leading to an array of products and patterns. He's been the chief scientist of several cruises and scientific explorations on board a variety of Indian research vessels. And of course, he is a prolific writer and has a number of publications in international journals. He's a great speaker and much in demand scientist at many international conferences. And also, he is an innovator and an inventor in his own right and has 4 international patents to his name. So it is, I could, of course, go on almost ad infinitum about his many accomplishments and still only have scratched the surface. So it is with particular pleasure that the National Maritime Foundation is able to welcome Dr. Ramadass and thank him for sparing his time to share some of his thoughts with us. So in the National Maritime Foundation, we have many societal tectonic really shifts in place which are going on. For a long time, we were concentrating upon only geopolitics and geostrategy. I'm happy to be able to say that this has now widened considerably to areas that are very, 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 very weak in India, notwithstanding the fact that we have needles of excellence, both institutionally and individually within India. And the NIOT is certainly one of these needles of excellence. And you, as an individual, Dr. Ramadass, are again a needle of excellence. Now, it is possible in physics, in mechanics, it is possible to balance a large and clumsy sort of structure upon a few needles of excellence. It is possible to do. But that particular end product is not going to be stable. For stable structures, we need to multiply these support pillars, and it is not enough for us to have a Dr. Ramadass in science, in underwater science, or to have a Justice Neeru Chadda as our sole representative in ITLOS. For example, on the one hand, we should be proud. And on the other hand, we should be ashamed. We should be proud because of their achievements. We should be ashamed that not enough of us are joining them. There are not enough Indians who are gnawing at their heels, saying, look to your laurels, Dr. Ramadass, here we come. And this is what is required. And the National Maritime Foundation sees this weakness amplified many-fold in policy making. So in policy making, there is a huge gap in terms of adequate understanding of the importance of the work that different ministries are doing in the underwater and in the maritime realm. There is a requirement for the Ministry of Environment and Forests and Climate Change to be equally invested in the work being done at NIOT. There is need for the ministries of help to look at what possible solutions can the NIOT's pioneering efforts mean for them. There is criticality in the Ministry of Defense, and yet the total number of Indian Naval and Indian Coast Guard officers who are intimately involved or aware of the challenges, the opportunities, and the risks that are involved in a range of Indian endeavor, from deep sea mining to the extraction of minerals by way of both polymetallic nodules as well as massive sulfides, to the issue of gas hydrates and whether and how we ought to be able to do that. There is not enough awareness of all this in the Ministry of External Affairs. And so even where we have leading edge, cutting edge, pioneering work being done in India, we are not using that as a means to prove, to show, to provide for manifestation of the vision of Sagar. So if we don't do that, Sagar remains only one more piece of rhetoric. For that rhetoric to be translated into meaningful action, science and Indian scientific endeavor must lead the way. So it is one great thing. Yes, it's a great thing that we have made low temperature desalination plants function in the Lakshadweep Islands. And they are functioning as commercially, economically viable entities, all thanks to the NIOT. But when the Maldives ran out of water, we didn't go, and our diplomats didn't go and say that we can set up for you a LTTD plant in some of the islands and atolls of the Maldives. We instead took them Syntex tanks and plastic bottles of water, thereby adding to the plastic waste problem. We could have. Why didn't we? It's not that we're not clever. It's just that there is not enough interdisciplinary, interministerial, interbureaucratic awareness of what NIOT can do. And it is here that the NMF offers itself to NIOT and to the Ministry of Earth Sciences as a bridge across a cross-cutting horizontal bridge, which will be able to address these many ministries, each of whom is like those blind men of Hindustan with the elephant. Each of them has some idea of what the portion of the elephant that they are dealing with might represent, but not all of them have a clear idea of the elephant as a whole. So I think that this partnership that I have started with Dr. Ramadass, thanks to the opportunity that was provided by the Konrad Adenauer Stiftung and the FICCI and Terry in our recently concluded set of workshops on climate change, blue economy, the various manifestations of that needs to be taken forward. And so I know that Dr. Ramadass, you and I are at the sunset years of our professional working, but it is at sunset that the sun is at its most beautiful. And it is at sunset that thousands and millions of tourists throng to places from where they can watch the splendor. So even though you may or may not hang up your boots very soon, I think that our partnership can only grow stronger to the benefit of the nation. And with those words, and with the permission of my chairman, whose presence we are deeply honored by, may I hand over the floor to Dr. Ramadass and move from being a talker to being an avid listener. Dr. Ramadass, the floor is yours.
Thank you, sir. Chairman Admiral Sunil Lambaji, Vice Admiral Chauhanji, Commandant Srivastavaji, Mr. Satya Shekhar, and Mr. Gonzalez, and Ms. Supriya Joshi, and many other office bearers and organizers invitees and attendees of this talk. A very good morning. This lecture is called Eminent Persons Lecture. But with all humility, I tell that I am well aware of the fact that I am among the eminent persons. I don't know how eminent I am, but I really feel that it's my pleasure and privilege to be among so many eminent personalities. Many of you are, I know that you are involved in protecting this motherland. While you are doing it, we are involved in making the motherland worth protecting. And after the eloquence of the previous speaker, I don't know how well this audience will receive my talk. And I really did not know what to talk about, because talking about ocean technology to this audience is like showing the torch to the sun. But there may be a lot of youngsters who may not know what's happening. So I thought of introducing this topic. Whatever is done by Indian Navy, most of it is actually a secret, and actually understandably so. But whatever is done done in civilian sector, that is also secret. That is really ununderstandable. It's actually regrettable. Hope this kind of opportunities for us allow us to introduce this ocean technology developments in civilian sector to the larger audience. With these few words, with the permission of the chairman, I will try to present my talk. For the want of any better title, I titled my talk as India's Scientific Endeavor in the Exploration of Ocean Resources. This is the organization of my talk. First, I would like to introduce inner space, that is oceans. Then some time will be spent on ocean resources. Then what's happening in the international arena that I would like to present. Then we take some national case study. Then we discuss about the emerging areas. And then I'll conclude my talk. We call our oceans fondly inner space. But as you can see from this slide, the first lunar calendar was prepared in 200 BC. That was the first well-organized either exploration or actually chronicling of celestial events. Then there were developments. Then Galileo's telescope was a major invention, and it opened the skies to us. But all this time, there was no systematic exploration of oceans. The first systematic exploration happened in 1831 to 1836 on board HMS Beagle, on which celebrated Charles Darwin was one of the scientists. So there was around 2,000 years lag in exploration of the oceans when compared to the space exploration. As you can see, the race into space, it started in 1950s, as well USSR and USA were in the race. And we all know by heart all the names, even the animal which has gone into space, we know the name, Leica, the dog. But are we aware of the name of the first person who went to 10,000 meters depth in the ocean? Or do we know the man who made a solo dive to 11,000 meters depth recently? No, I think some of us may know, but many of us may not know. And if you see, even in India, India's Space Odyssey started in 1960s, and now we have graduated up to Mangalyaan, and Chandrayaan-2 has been completed. We are in Chandrayaan-3, and Gaganyaan may happen in 2022. And what about Samudryan? Who is doing it? And why this kind of, I don't call it discrepancy, but why this is actually well hidden? That is because if you want to look at the satellites of any planets or Saturn rings, what all you have to do is that you can take a high-powered telescope on your terrace. You can focus if the conditions are good. You can have a very good glimpse of that one. But if you want to know what is below 100 meters, I'm not talking about thousands of meters, 100 meters below the sea surface, in your own backyard in Bay of Bengal or Arabian Sea, can you see it? No. You need to have a ship, you need to have a boat, you have to go there. Electromagnetic waves don't travel, then you have to have some kind of sonars, and you may be seasick. It is really difficult. So I say that conquering inner space is much more difficult than the conquering outer space, but it may be more important than, at least immediately important than conquering the outer space. And coming to India, it is very important. India's exclusive economic zone, that is actually around 2 million square kilometers. But if you add extended exclusive economic zone and also some areas given to us by United Nations, International Seabed Authority, our EEZ is almost equal to the land area. So we are actually blessed with so much of EEZ, all resources are there to be tapped. In this context, actually, the NIOT was started in 1994 with a mandate to develop reliable indigenous technology to solve various engineering problems associated with harvesting non-living and living resources. We use the word harvesting very consciously. We don't call it exploitation. That has a bad connotation. So NIOT concentrates on different areas. We have a strong group working on energy and fresh water. We started with converting wave energy into electrical energy. We proved the concept. Then we moved into ocean thermal energy conversion. As a byproduct of that one, we hit upon something called low temperature thermal desalination. We take ordinary seawater, create partial vacuum over that one, and water boils at room temperature, leaving the salts behind. The water vapor rises. To cool this water vapor, we take water from 1000 meters water depth, which is at around 5 degrees, 4 degrees centigrade, and we use it for cooling the vapor, which becomes fresh water. This is especially suitable for islands where the depth is very close to the shore. We have successfully installed these plants in Lakshadweep Islands in the western coast of India, and we are in the process of now establishing it 6 more islands. I am proud to say that it's not just quenching the thirst of the islanders, but it caused a social revolution there. And many people are really interested in improving their qualifications, studying engineering and technology. It improved their health condition in such a way that the diseases related to water, they fell down by 90%. And we have a strong group working on deep sea technologies. You'll be seeing it in the later slides. We have a mandate to deploy and maintain the observation systems, ocean observation systems, which also give the tsunami early warning. We have a strong group working on coastal and environmental engineering. We have recreated the beaches where, which are lost in Pondicherry and some parts of Tamil Nadu. And we also have strong groups working on marine sensors, marine instruments, ocean acoustics, marine biotechnology. And we have a small fleet of vessels. Our flagship is Sagar Nidhi, 5,000 ton displacement, 100 meters vessel, which can go up to Antarctic water. It's an ice class DP2 vessel. And then actually coming back to this ocean resources, as we all know, 71% of the Earth is covered by oceans. It's not just a cliche. It is actually, that means that 70% of the ocean Earth's resources are still hidden from the humankind. In this 30%, hardly 5% is available to us for habitation and for exploitation. And we have been using and abusing these things for thousands of years. So if we can judiciously tap this 70% resources, then how long they can sustain us. But there is a catch. We have to use them very judiciously. We cannot abuse them as we have used the land-based resources. As you can see, the problem with these resources are actually land resources are that they are very unevenly distributed. It's an irony that the poorest of the continents has the is the richest in the minerals. But these are not going to last forever. As you can see from this slide, some of them are going to last for centuries, but some will be disappearing very soon in a few decades. So what are the alienating factors? We have to explore more. This is where the oceans come into picture. We have to develop better technologies, and they have to be environmentally friendly also. And we have to classify sub-economic resources into reserve actually. So hitherto unusable resources should be used. So ocean mining looks imminent. The question is it imminent? If it is a no, it is only when and how. It's only a matter of time. So this is not a new concept. In 1870 itself, Jules Verne, in his 20,000 Leagues Under the Sea, he guessed that there are minerals in the ocean depth. Ironically, in 1872 to 76, HMS Challenger on board, they sampled the polymetallic nodules at 5,500 meters water depth. So there is no unique way of classifying these ocean resources, but for our interest, we have classified them into non-living and living. In the non-living, again, there are renewable and non-renewable energy resources are there. So today we will be talking more about seabed minerals. Energy and freshwater, of course, NIOT and the Ministry of Earth Sciences has been using. We have been harvesting these things, but today's talk will be concentrated on seabed minerals. So these ocean minerals, you can see seabed minerals are oil and natural gas. You may be surprised that they are called minerals, but they are minerals. Diamonds, gas hydrates, polymetallic nodules, cobalt dust, sulfides, the hydrosomal sulfides. Of course, there are dissolved minerals like salts, uranium, and other metals. We are not going to talk about them today. So beyond 200 nautical miles from the shore, beyond EEZ, there are resources available. These are governed by United Nations, International Seabed Authority. So the area that is given to the member nations is called the area, and it only refers to the seafloor, not to the waters. And the waters, you have that right of innocent passage, and a portion of all profits that are going to come, that should be shared with the developing countries, and it's called common heritage of the mankind. So there are many minerals, but prominent of them are actually, you can see gas hydrates. They're actually methane deposits. We'll be talking about them in detail later. They occur at around 1,000 meters to 3,000 meters water depth in the continental margins. And then polymetallic nodules in the shape of some potatoes strewn on the seafloor. They are rich in cobalt, nickel, and manganese. They are available at beyond 5,000 meters in the abyssal plain. And in the seamounts, there are cobalt truss which are similar to nodules, but they are actually covered on the sides of the seamounts. And beyond 2,500 meters water depth in the mid-ocean ridges, there are hydrosomal sulfides which are rich in, again, many of the very valuable metals in the form of sulfides. So gas hydrates, they can occur in the permafrost regions, or they can occur in the marine sediments. They are nothing but they are clathrates. They are actually methane gas, whether it is biogenic or thermogenic. When it is actually generated in the below the seafloor, when it tries to escape, it mixes with the seawater and forms some crystals, crystal-like substance. Actually, it's like camphor. 1 cubic meter of this material can contain 163 cubic meters of methane gas. If you can tap them, actually, at least in the margins of India, for example, in Krishna Godavari Basin, 10% of that can sustain India for 100 years, it is said. Of course, it has to be taken with a pinch of salt because these are not very evenly, uniformly distributed minerals. Except for China and Japan, so far nobody has ventured into tapping these minerals from the marine sediments. Polymetallic nodules, as I told, they are rich in cobalt, nickel, manganese, and iron. Okay. They are available at around 5,500 meters. It takes millions of years for them to form on the seabed. But one good thing is that they are not stuck to the seafloor. It is easy to pick them and mine them. India is called pioneer investor, one of the few countries to actually interact with the International Seabed Authority or United Nations. And we were given the status of pioneer status. Later, when ISBA was formed, India was one of the first signatories. Here, I want to really dispel one. Actually, there was a misunderstanding that India was given 150,000 square kilometers because we have not done the exploration properly. Half of it was taken away. Actually, when I visited Japan with our ministry officials, ambassador himself was telling that he was ashamed of that fact. Then we had to respectfully tell him that that's not the case. Actually, we have surveyed all the area, and as per the agreement, we are supposed to give back 50% to the International Seabed Authority. International Seabed Authority. So we have given it back to International Seabed Authority for giving that area to other developed nations. So it was a misconception. These 75,000 square kilometers are still with us, and we are exploring this area. And very soon we may be able to demonstrate exploratory mining in this area. So this area is rich in nodules, which contain 92 million metric tons of manganese and cobalt, nickel, and copper. And the percentages are given here. As you can see in the map, it is actually around 2,400 kilometers away from the coast of India. It is at around 13 to 15 degrees south and around 79 degrees east. As the oft-repeated joke says, by the time we reach the site, 50% of the team is seasick and 50% of the team is actually homesick. But the weather is really treacherous there. It's always turbulent, and we are given this area. And National Institute of Oceanography and National Institute of Ocean Technology, we have done we have spent good number of years actually at this place, and we learned so much about this place. And polymetallic sulfides, when these tectonic plates meet, these gaps, hot magma comes out and the cold water seeps in. Together, they make a geyser-like system where these hydrothermal fluids come out like actually geysers, and the whole area around that place is actually mineralized. So these minerals are very actually rich in manganese, silver, chromium, lead, zinc, and even gold. Again, we have signed an agreement with India has signed an agreement with the International Seabed Authority. The area given is around 26 degrees south and again around 79 to 80 degrees easting. And our sister organization, National Center for Polar and Ocean Research, under the Ministry of Earth Sciences, they are having a mission mode program, multidisciplinary program for exploring this area. And another resource is cobalt crust. It is very much similar to nodules, but it's in the form of a crust which covers the sea modes. These cannot be easily picked, but it should be scraped. So these are available. So what stops us from mining these resources? Because inner space is difficult to conquer. It's a dynamic medium. Each 10 meters of water column gives rise to 1 bar extra pressure. That means 6,000 meters, we have 600 bar pressure. No ordinary equipment can survive there. It has to be either cased in pressure compensation cases or pressure cases. And the density and salinity variations are there. Temperature varies from 30 degrees centigrade to around 1 degree centigrade. Corrosion is there. And the main problem is the absorption of electromagnetic radiation. No electromagnetic radiation penetrates the oceans beyond a few tens of meters. So we have to depend on the sound, which is actually very slow when compared to electromagnetic radiation, and it can carry only very little information. So unless you have a cable, you don't get to control what is there at that depths. So, but how do we survey these areas? We have seismic, acoustic, geophysical, and imaging techniques available for mapping these resources. For example, this is actually a cartoon gives you an idea of how the seismic survey is done. We have a source, that is an air gun or explosion or something like that. It's a source, and we have got a sensor stored behind the ship arranged at particular spacing. They pick up the refracted and reflected signals. This multi-channel seismic survey is mostly used for oil and natural gas and gas hydrate surveys. Next one is, of course, the acoustic survey. So there are different kinds of sonars, for example, echo sounder, which can be used for measuring the depth as well as mapping the seafloor. Side scan sonar for visualizing what is on the seafloor. Sub-bottom profile, which gives you the idea of what is below the seabed. So in oceans, we use sound to see. So these are the pictures of single beam, multi-beam, side scan, and some kind of special kind of sonars. But how do you carry all these things to the bottom, actually? So we have to use underwater vehicles. There are many classifications of underwater vehicles. For better understanding, we call them manned, unmanned vehicles. There can be manned vehicles like they can be either navigated or they can be like a bathysphere with a cable. We can go to one spot. And in unmanned, there are varieties, tow bodies, okay, which are towed behind a ship, remotely operated vehicles, autonomous underwater vehicles, and seabed crawlers. Okay, so here we are going to talk about everything else except the military submarines for the obvious reasons. And survey vehicles, one is, as I said, actually it's just a tow. You can see just it's a tow body on which the sensors are mounted, and it is hydrodynamically designed in such a way that when it is dragged behind a ship, it actually maintains the orientation and it collects the data and it is used in the mapping of the seafloor. And another version, another vehicle is a remotely operated vehicle. It is tethered. The tether is called umbilical cable. We can supply power, we can supply signals to that, we can get back the data, and we can get back the video signals, the imageries, all those things. And this umbilical cable also is actually a mechanical cable which can bear the weight of this machine. So payload can be anything. It can be sonars, lights, cameras, sampling devices. Actually, we can even call it actually, we can take the lab to the deep. Okay. And another version is actually autonomous underwater vehicles. Because of the tether has got a very big drag. So the area covered by remotely operated vehicle is very limited. To overcome that one, we can use autonomous underwater vehicles where there is no tether. But here you don't get to see what it is doing. You have to pre-program it and it will do its work. When it comes back, you will actually if at all it comes back, you can collect the data. You have some rudimentary control and rudimentary communication with them by means of acoustics, but not much of control is there. So once we map it, how do you know how much abundance is there on the seafloor? There are several kind of sampling devices. There are graphs, there are dredgers, there are corers. With the help of these things, we estimate abundance. How many kilograms of the ore is there in 1 square meter? And what is the grade of this ore? We can estimate. Okay, so this work has been done by National Institute of Oceanography, Goa, in the Central Indian Ocean. Then coming to, okay, now we have assessed the wealth, but how do you mine that wealth? We need to have some vehicles which can go onto the seafloor and collect that mineral resource. So there are tracked ones are there. Some Archimedes screw is there. Just a simple sled or skid is there, which can be dragged on the seafloor. So there are several countries, for example, China, Japan, Belgium, India. They are all actually very active in this area. And I am proud to say that India is not lagging behind. In fact, India is one of the leaders in this technology. Okay, now we have a vehicle that can go there, crawl on the sea bottom. But how can it collect the mineral there? There are different kinds of based on what kind of mineral is there, the different kind of collectors and pickers are there. For example, for polymetallic nodules, you can have a mechanical device which actually harvests the potatoes, or it can be even a hydraulic lift system can be there. So once we collect that mineral, how do we bring it to the top? It is 6,000 meters to the mothership. So one idea is that we can have a continuous line bucket system. This was tried, but one thing is it was only suitable for very shallow depths, maybe for some kind of diamond mining and all. But when we go to thousands of meters, this is a very cumbersome procedure. Number of buckets are actually connected to a wire, and that is actually circulated, but it's not a practical solution. Next one is to have autonomous shuttles, which can go there, collect the mined ore, and then come back to the mothership. But this was not practical, at least with the technology that is available right now. The most commonly used method is called G.A type method, actually, in which the ship is there, there is a vertical riser, the mining machine takes the nodules and pumps it using pumps. It can be a single pump at the bottom, or it can be different pumps all along the pipe. And this riser, it can be a rigid one or it can be a flexible one. But for commercial mining, mostly the rigid one is used. At least for the exploratory mining, many people are using the flexible riser method. Coming to environmental aspect, United Nations International Seabed Authority is hawk-eyed, and they really watch each step we do it. There are very good regulations. We have to first collect the data, environmental data a priori to your explorations, and after the exploration again you have to do the environmental data collection, and you have to prove that you have disturbed very little. And you can see at every level we make some disturbance. And after getting that thing back, actually, again, we may leave something out. That also has to be left out at one particular depth, causing minimum damage. So with all these things, several countries are actually, as described here, and they are into either technology development or only for technology exploration or even demonstration. Only USA, Japan, Belgium, and India have done the demonstration so far. So it all started with the Glomer Explorer. This is famous American ship. It's actually a defense ship converted into a mining ship, and it was mainly meant for lifting one sunk Soviet submarine. But at the time, they also collected some 6,600 tons of nodules. It is the biggest collection of nodules so far in the oceans. And of late, Belgium is very active, and as we are talking, their Patania 2, this mining machine, is in the ocean collecting nodules at around 4,500 meters water depth. And of course, Nautilus Minerals, actually, they have come out with a system for mining the nodules as well as the hydrosomal sulfides. And Japan is the most successful country in this aspect. Of course, they are fortunate that hydrosomal sulfides are there within their EEZ, and they have demonstrated end-to-end system to collect and pump the nodule, pump these hydrosomal sulfides to a depth of around 1,600 meters. So coming to India, India Polymetallic Nodules program spearheaded by Ministry of Earth Sciences. It has 4 components. One is exploration, environmental impact study, mining technology development, and metallurgy. And these are the institutes that are involved. NIOT from Ministry of Earth Sciences, NIO Goa from CSIR, and again Institute of Minerals and Materials Technology, IMT Bhubaneswar, that's also a CSIR organization. So it all started in the 1990s when NIOT was established in 1994. We approached IKS Germany. They have a mining machine. It's an experimental mining machine developed by University of Siegen. And we adopted that system. We went for flexible riser system. One is that it's easy to implement. At least we thought it was easy to do it, but now later we understood that it is easier said than done. But we can use multiple mining machines from the same mother station, and failure of one system will not affect the total system, and it is less cost intensive actually. So this is the sand mining system that was developed by IKS Segan. We adopted it. We made it amenable to deep waters at about 500 meters. And at the same time, we signed in 2002, we signed a contract with International Seabed Authority for 15 years up to 2017. Presently, it is extended up to 2022. We gave them a plan for phase-wise development of mining system. First, it's only exploration, then actual demonstration at 500 meters, then demonstration at 6,000 meters. So as you can see, the sand mining system has been converted into a nodule mining system. Here you can see it's only a sand cutter, whereas here we have made it amenable for collecting the polymetallic nodules that are available in the seabed. So in the late 2009 or so, we have demonstrated this system at 500 meters water depth. At 500 meters, there are no polymetallic nodules. We laid some artificial nodules and we collected them and pumped them. And India was the first country to demonstrate the end-to-end system even at 500 meters water depth. But 6,000 meters is totally a different ball game. So soil is very soft there. It's like a grease. Whatever you keep there, it sinks. But to bring the soil onto the surface and test it, it changes its properties. So we need to test the soil and the in situ conditions. That we have done it by developing one in situ soil tester. As you can see, at 5,462 meters, we deployed the system and measured the soil strength. That gave us an idea what is the shear strength, which is around 4 to 5 kilopascals, and what is the bearing strength, that is around 16 to 20 kilopascals. So this gave us an idea how to make a mining system for that. This thing, it's a tracked vehicle, and we calculated what are the different forces, and with these things, how much power is required, we estimated, and we made a cable and winch for that one. And so we arrived at this configuration. As you can see, there are ship systems, there is an umbilical, there is a pump frame, there is a mining machine, there are several electrical systems, and undercarriage is there, and systems, instrumentation controls and navigation systems are there for navigating the system on the seabed. So as you can see, we sized these components. We started with, there are no ready-made components for underwater users. We took many pumps and other things which were used for slurry pumping on land. We converted them into underwater slurry pumping machines. And we had to really scout around for using right kind of riser system, which can withstand around 120 bar pressure for pumping the nodules to the surface. And this is all things you're seeing are made in India, or rather at least components were procured from the international market, and they are integrated and tested in India. And this is our portable laboratory in which we sit and drive the mining machine, which is on the seabed. You can see these are all live pictures from the ocean depths. So we started at around, actually, after demonstrating at 500 meters, we developed it for 6,000 meters, but we went in steps. First, we demonstrated it at around 890 meters in Bay of Bengal, where the soil is very soft, and we have demonstrated at around, it has crawled for some time on the seabed. So with this confidence, actually, we have gone to higher depths, to Central Indian Ocean, that is around 5,500 meters water depth. And in March, April, this underwater mining machine, which it was demonstrated only for locomotion. It's not for collecting the nodules. We have not got permissions for picking up the nodules yet. We are supposed to do some environmental survey. But locomotion was demonstrated at a record depth of 5,270 meters. With some pride, I can say that my colleagues, they went on ship and they could do it. And in the world, this is the most successful demonstration of crawler at those depths. Other countries have done up to maximum of 4,500 meters, but it is a qualified success. But ours is actually an unqualified success at 5,270 meters. You can see some underwater pictures. All the components, electrical, electronic, mechanical, hydraulic systems They worked like charm at that place, and the live system was lifted at in the middle of the night after successful demonstration of the system there. So the next trials will be with pickup systems, with a pump to pump, positive displacement pump to pump the nodules to the surface hose, and deployment and integration, deployment, launch, recovery. It is going to be a really challenging task. And if everything goes well, we would like to demonstrate these systems by 2025. And whatever nodules were collected, not by our trawler, but by dredging equipment and all, these were actually given to IIMT Bhubaneswar, where they have established a plant for extracting copper, cobalt, nickel, and some sheets were really made using this minerals actually that metals obtained from the ore, and the process has already been, efficient process has already been established. So this is a success story, and you can, this is actually, this book is there. It's actually edited by one eminent scientist, Dr. Rahul Sharma. You can download this book, and this contains the very good description of the international and national scenarios. And now, so far, we have actually seen what we have done on the seabed. But before going there, actually, we have to examine the water column and also survey the bottom. And to do even engineering intervention, we need a work-class remotely operated vehicle. So at NIOT, we developed this vehicle. At that 7,000 meters, the cable has such a drag that the ROV cannot move at all. So for that matter, what we have to do is that we made something called tether management system. As you can see, there is a winch here, underwater winch, which has a thinner cable, which can be actually used as an umbilical for this ROV. So this is actually akin to similar to satellite launcher and satellite. They go together to the designated water depth. There, the ROV, which is a satellite here, that actually goes out and does the work, swims around, collects all the data, maps the seabed. And again, after work is over, it is wound back. So it is actually, unlike space, we retrieve it actually. They go, it docks here, and the whole system is lifted using the umbilical cable. And this has been extensively tested, and it has been used around 50 times, more than 50 times beyond 1,000 meters water depth, up to a distance of 5,000 meters. You can see it has been it launched using a special launching and recovery system on board our vessel Sagar Nidhi. And we have gone to a gas hydrate site at the 1,000 meters, and we proved that there are many markers or proxies for the gas hydrates there. Then we went to that PM and Polymetonic Nodules site in Central Indian Ocean. At 5,200 meters, we used this vehicle. And at hydrothermal sulfides at 26 degrees south, we went there. But we can only carry around 25 scientists. So for the benefit of our people, we have webcasted this, live casted this operation, entire operation to our headquarters, and people could watch it on their computers and mobiles. Even now, when we helped Indian Air Force and Navy while searching for missing aircraft AN-32, while actually checking for the targets, these visuals were actually broadcasted live to the authorities, and they could watch it on their mobiles and verify the targets actually. So you can see the pictures here. These are actually pictures of pillow basalts, which are in the hydrothermal sulfide areas. So, and we also had the privilege of working with DRDO and Indian Navy when Varunastra torpedo, which was about to be inducted into Navy, when it was fully instrumented, one was missing at around 200 meters depth off Vishakhapatnam. NIOT was called for the exploration and this thing, search and recovery. And we did it actually using a sub-bottom profiler. We saw that it was embedded on the seabed actually. And by disturbing that one, we recovered it. It was a joint operation with Indian Navy and DRDO. And also, again, this same ROV was used for searching target verification in missing aircraft AN-32. And for industry, the 500 meters one or shallow water remotely operated vehicle is very much important. So when we had the demand from the industry, we made a vehicle which is usable at 500 meters water depth, which can be launched from a small boat. But we also made it amenable for polar exploration. You can see this is the vehicle and this is the control station. So we have taken it to Antarctica in our in 35th exploration, I believe. Then first we used it at Priyadarshini Lake in front of MATSYA, our station there. And you can see it was launched. We put up a tent there and we launched the PRO, we call it, Polar Remotely Operated Vehicle into Sagar in Priyadarshini Lake. You can see a person actually helping us in launching this one. He was very happy because the outside temperature was -20 and water temperature was 0 degrees centigrade. In fact, he was feeling warmer than surrounding temperature. These are the algal mats on the Priyadarshini Lake. We gave these samples to the biology people for analysis. And very soon the lake froze. Then we had to shift our arena to the shelf where the continent meets the ocean. And we surveyed that area in an appropriate location. By helicopters, we shifted our equipment there. The temperature was around -20 degrees centigrade. All the cables were like sticks, very stiff. So we launched my colleagues launched the vehicle there, and we tried to go below the sea here, the sea ice here, and up to 60 degrees, 60 meters water depth, we could operate the ROV and collect the data. And you can see this is a sonar image of that is ice. And it is a work in progress, but the same ROV was used for the exploration of coral reefs in Andamans, and we used it for finding one missing barge in Chennai Port Trust. We also use it for search operations of underwater missile. I'm not permitted to tell the details, but we could help DRDL Hyderabad in actually searching for the debris of their lost vehicle. And we have transferred this technology to L&T and BEL Bangalore for the production of these ROVs in India. And coming to another resource, gas hydrates, though it is available in our backyard, in our Indian margins, it's very difficult. There is no technology for this one. India is involved in developing a coring system with one American industry, which can replace the drilling vessel. It can go up to 3,000 meters and take a core of 100 meters. And also in the laboratory, we came out with some kind of studies, numerical as well as experimental studies, and we found that if we give 1 unit of energy, we get 3 units of energy back with these gas hydrates. It is possible to extract these gas hydrates. So now we have covered all the unmanned vehicles. So this is the portfolio we have at the Ministry of Earth Sciences and NIOT. We have a mining machine, we have a deep water ROV, we have a shallow water ROV, we have an in situ soil tester, and we have a deep water coring system. Very few countries in the world have this kind of a galaxy of equipment there. But these things have some limitations, because if we have an ROV, endurance is unlimited, but it's tethered, so intervention capability is very limited. AUV is endurance is maximum 2 days, but it is untethered. That is an advantage, but the intervention capability is still very primitive. It's only used for only exploration or mapping the resources. Whereas a human submarine, we call it human submersible, scientific submersible, it also has limited endurance, but it's untethered and intervention capability is excellent. So we are into now human research submersible, Samudryan. Somebody asked actually, why do you want to do it? Tell it in one line. My response was, seeing is believing. So there is no better sensor than human eye, as Leonardo da Vinci said. Okay, so we need a small mobile undersea human occupied research vessel, which can go up to 6,000 meters, which can take trained human beings there. And it has the capabilities of both ROV as well as AUV. So it is actually the expertise developed in this process. Actually, it's a capacity building. It can really open new areas of research and development. So you can see this is not just a fancy equipment. This has been used by US not only in filming Titanic or surveying Titanic, but also in even extracting one lost hydrogen bomb in US and discovering hydrothermal vents by Japanese by using their manned submersible Shinkai 6500. So with all these things in mind, we started next up Samudryan. So we are in the process of developing MATSYA 6000 Indian manned submersible. So the history says it started, it's not a new idea. In 1932 itself, Charles William Beebe, he went up to around more than 1,000 meters water depth using a bathysphere. It has no propulsion system. It can go only to one point and come back. But the idea is that almost 90 years back, this was done. Actually, what was the technology available at the time? So many of you can identify this character, Professor Calculus from Tintin comics, but it is actually not an entirely fictitious character. There is a man called Auguste Piccard. He is a physicist, and he was working with space balloons. Later, he developed a manned submersible which can go up to 4,000 meters water depth. It was a record at that time. Later, his son, along with his associates, went up to 10,916 meters in 1960s, mind you. They have gone up to this depths in Mariana Trench. But what does a manned submersible, what are the components of a manned submersible? Obviously, manned submersible should have a man or human. It can be woman also. So we need operator or observer. But they have to be, we cannot send only trained people. We have to send ordinary scientists also. So they should be in a 1 bar atmospheric pressure, that we call it short sleeve environment. They should be able to breathe normally. So they are in a pressure hull, and 1 bar atmosphere is maintained, oxygen is given, CO2 is removed, temperature is controlled, humidity is controlled. He feels normal. There are some viewports, acrylic viewports through which he can see. So it needs some kind of life support for supplying oxygen, for carbon CO2, and it needs an exostructure, and it needs ballast and trim to maintain its orientation. It needs propulsion system to go around. There is no point in getting stuck at one point. And it needs fairings and sail, and it needs a specialized launching and recovery system. In the world right now, 5 countries have been operating these manned submersibles: America, France, Japan, Russia, and finally China. China has now Geolong, a celebrated manned submersible. They have gone up to even 1,000 meters recently, and they have been deploying it in Indian Ocean at many times actually. So India has to match them at least. So with this in mind, we have proposed a manned submersible with these specifications. It can go up to 6,000 meters because there is no further depth in Indian Ocean. It has 3 viewports. It can take 3 human beings. Endurance is 12 hours normally, but if they are stuck, if they are waiting for rescue, it can be 72 hours. We are even trying to make it 94 hours right now. And it can move with 3 knots speed. It weighs around 20 to 25 tons. And these are the major critical subsystems and subcomponents. Mechanical, there is a personal sphere. It has to be made with a special grade titanium alloy. It has to be made in the sphere. It has to be around 80 mm thick. It should be in 2 hemispheres. It has to be welded. It's not an easy task. We are trying to do it for the first time in India with the help of VSSC, ISRO, Trivandrum. And of course, there are all other things are common to remotely operated vehicles. So these, actually, we are in the process of already, we are halfway through in realizing these things. We have also signed an agreement with the DNV Norway for classifying or certifying each component from the design stage, procurement of materials, fabrication, testing, integration, and testing in the field. So each part is actually, because it's a mandated technology, it has to be certified and classified. And you can see it's almost taking the shape, the configuration and the shape has been finalized. We are in touch with IIT Madras for the hydrodynamic testing. We have been partnering with different agencies and organizations. In fact, we are in touch with Indian Navy right now, and because launching, recovery, and piloting these things is not an easy task. But the details, we are not ready to share the details yet with the audience. So with all these things, you can see Ministry of Earth Science and NIOT has covered many areas, and still we are actually, if you see tectonic activities at 3,500 meters in the Sumatra Ridge area, we have not covered it. But if you can see, we covered gas hydrate area, and we have covered polymetonic nodules area, hydromal sulfides, and we went up to Antarctica. So this is the expertise that is actually gained by NIOT and Ministry of Earth Sciences and other our sister organizations in Ministry of Earth Sciences as well as CSER. And these are the emerging areas. Okay, now everything is actually coming back to biomimetic. We have to imitate the nature. We have to make vehicles which are similar to these organisms like fish or whales or something like that and all, which can really sustain themselves underwater. Swarm robotics, in the sense that you can see the formations that are actually formed by birds or fish. So, but what is the coordination between them? They don't have any distributed control or anything like that, but they have some kind of nearest neighbor interaction and monitoring the environment. So that we are trying to adapt. And alternative navigation, that is non-GPS, and generation of new observation systems. These are some of the emerging areas we can think about. The summary of my talk is that ocean is a treasure trove of strategic minerals. As we are actually exhausting the land-based minerals, we have to go into ocean mining. That is imminent. And technology is slowly but steadily maturing. And several nations and conglomerates are developing these technologies. Under Ministry of Earth Sciences, India, NIOT is in the process of developing technologies, but we should interact with the industry and Indian Navy for ramping this technology. We have to sensitize the industry about the benefits of mining as well as the precautions we have to take while mining. And recently, Government of India has announced a deep ocean mission. It is spearheaded by MOES, but it's a multi-sectorial and multi-institutional mission in which there are 6 components ranging from technology development, ocean thermal energy conversion, new generation observation systems and climate sense systems, and marine biotechnology. Several components are there in that one. So the stress is on expertise, equipment, environment, ecology, and finally economy. So this is my guiding principle when I started my career in ocean technology. This Glomer Explorer, they released a statement after this one. Somebody asked whether this impossible task is possible. Their answer is, the impossible is indeed possible. When talented engineers, of course, in parentheses, they are my words, and scientists, with the courage to take prudent risks, are provided an incentive to stretch the state of the art. So I really believe in this one. With these few words, I conclude my presentation, and I thank the organizers for giving me this opportunity to share our experience with the audience. I know many of you, they know about these things already. It is like selling ice to Eskimos, but I thought we should not work in silos. We should know what we are doing. Many a time when I give a talk, people come and say that we are not aware of the availability of these technologies in India. These are not the technologies which are just tested once and put in the shelves. These technologies are available for usage, and we have already transferred the technology with the industry. We keep telling them that just by transferring technology and taking some few crores of rupees, our responsibility is not over. We will hold your hand till you realize the project. So I thank the organizers once again and the participants once again for giving me this opportunity and for your patience. Thank you.
Well, thank you very much, Dr. Ramadass. We had lifted the expectation bar before you commenced, but I see that we have not lifted it sufficiently because you have crossed it with such ease. So I do need to immediately say thank you, and I'm sure I echo the views of every one of our numerous participants. We had over 70 participants, 72 during the talk. One or two people had to leave urgently now. But let me go quickly across to the first of the questions. Before that, I would like to tell everybody that though you haven't all put questions into the chat box, should you desire to make a comment, please keep it brief. If you desire to ask a question, please keep it succinct. If you then just put on your video at that point in time, I will recognize you and be able to ask you to deliver your question or your comment. But first, there is a question from Aditya Sharma. And with your permission, Aditya, I'm going to read it out. It says, it's a number of questions bundled into one. First, he says, what is the current state of the Deep Ocean Mission and the Samudryan Project? This, I think you have covered adequately, unless you would like to amplify some point there. The second question is, what international collaborations has India carried out so far in deep sea mining and in gas hydrate exploration? And I too would like to seek a clarification on this, apart from the usage of the Japanese vessel in the beginning and the 5-year plus 5-year contract with the United States of America for gas hydrate mining. Perhaps you can update us on this issue, because once again, there are international cooperation ramifications of everything that NIOT is doing. And the last question from Aditya is, are gas hydrates, how close are we to commercial exploitation? We often say, as once again in amplification of his question, we often hear it said that, you know, Indian gas hydrate exploration processes are like the Shakespearean cat, which wants to get the fish, but it doesn't want to get its paws wet. And India is therefore, as a government, possibly somewhat risk averse, and it is likely to be overtaken by more risk prone countries, particularly in the case of Japan and possibly China. So I think we can perhaps start the session with these questions and then move on to some others as they come up. Thank you, sir.
Yeah, I'll take the first question about the Deep Ocean Mission. It has been announced by Government of India, but we have submitted the cabinet note right now, and we are waiting for the final approval. Second thing is that about the Samudryan project, we have started it 2-3 years back with the collaboration of many institutions like IIT Madras, VSSC Trivandrum, and NSTL Visakhapatnam. Many collaborators are there. We have already completed the design, and we have already made a shallow water human sphere. Many components are being procured and getting qualified. And God and government willing, by 2025, we'll be able to launch this Man Submersible for deep waters. And about the international collaboration on the deep sea mining, the first collaboration is, of course, we are a part of signatory. We are signatory to UNCLOS and later agreement with the International Seabed Authority for Polymetonic Nodules and hydrogen sulfides. There, whatever we do, we have to share it with the international community. That way, we submit our annual reports, we submit our environmental impact statements, and we get a lot of feedback from that. But as for the collaboration, except for University of Siegen, from whom we got one shallow water mining machine crawler, don't have much of international collaboration. We made one that remotely operated vehicle. We started with the collaboration of one Russian Academy of Sciences institution called EDBOE. But later it fizzled out. Actually, we had to be on our own. We don't have much of interaction with the international agencies for the mining. Recently, we signed an agreement with Russia, one agency in Russia, Kilo State Research Center, for exchanging the cooperation in mining and the Man Submersible. But it is yet to take off. In the gas hydrates, yes, there was actually Indo-Russian gas hydrate center that was established at NIOT. It has got actually this gas hydrate research in India has two aspects. One is done by Ministry of Petroleum and Natural Gas. They are doing actually ONGC. They have hired drilling vessels from abroad and all, and there was some mega campaigns for obtaining the cores and for establishing the availability of gas hydrates in Indian continental margins. It was very well done, and the data was shared with many of the agencies, including NIOT. But on the technology development side, there is not much of collaboration. We tried to collaborate with different countries. America is not interested because they have got enough shale gas and all. But they want to use Indian money and Indian resources in India and this thing, and they want to get the knowledge. But they are not really interested in developing a technology. Japan and China, we try to interact. They are not interested in sharing their technology. And I also believe that their demonstration and their success was not completely unqualified. There are some question marks about the efficacy of their technologies, so they were not sharing. So we, on the technology development side, we developed a underwater coring system which can go up to 3000 meters and take a core of 100 meters. But many of you may know that taking 100 meters core is not always enough, because gas hydrates can be much below that one. But right now we have the technology only up to this point. So that was a collaboration with a private industry in the United States. But we don't have any collaboration with any other government agency of any other foreign country actually in the gas hydrates. About the commercial viability, right now we can only prove the first point is to whether it is mining or gas hydrates. My view is that first we have to prove the technical viability and then environmental viability. Then only we can talk about the commercial viability, because commercial viability depends on many other things: international metal prices and environmental hazards, and what is the accessibility of that area, what is the grade of the ore that is available, what is the abundance. So there are so many issues, and the technology evolves. So today it may not be commercially viable, but tomorrow it may be commercially viable. So one thing is risk averse. That actually being averse to risk is a problem. But one thing is that we should be aware of the risk. We should know that first somebody says, do you say it is the future fuel of India? I say, I don't know. Then do you say that it is not a future source of energy? I say, I don't know. Then why are you working on that? My answer is that because I don't know. I have to know. So if you want to do only which will be eventually success, actually there is it's really not a correct in my philosophy. You have to take risk. We have to have a pilot experiment to be done, and we should have the courage to call it off if it is actually not available. It's not. It is proved commercially not viable, but it's worth taking that risk. But as he rightly said, actually, as the Vice Admiral rightly said, we are not taking the risk, so we don't get this cat will not get the cream because we are not getting wet actually. But I think things are improving, and our estimates are that it's actually energy efficient, but it is very unevenly distributed resource. So it's not like oil field where you can use it for years. Okay, this may get exhausted in no time. So we may have to involve horizontal drilling. Vertical drilling may not be enough. So unless you do it, how do you know whether it is worth doing or not? there is no substitute. So we have to get our feet wet. So that I hope I answered your question.
Yes, indeed you did. Thank you so much. There are, of course, multitude of questions building up. So let me ask a question from Nitin, who says that this is an ethical question which many people who are engaged in conservation, in ecological protection ask. And that is that do we as humans have the requisite knowledge to avoid environmental damage likely to be caused by deep seabed mining? And that includes the humans who are in the International Seabed Authority, who lay down the norms for environmental impact assessments. And we are all aware, sir, of the problems that occurred in Papua New Guinea when the environmental impact assessment was published and then soundly and roundly denounced by a number of independent observers, saying that the entire thing had been cooked up in favor of the Australian company involved. So there is a question that is, do we have requisite knowledge? If you take a case of a submarine which is manned and it uses, say, light just to see for the individuals who are in the submarine, then that light which penetrates and hits creatures who actually managed to evolve through bioluminescence, what will happen to those creatures and what impact will that in turn have on the entire food chain? And so the question is a real question, and the answer is also obvious, that you will never know everything. So I thought I'll pose both ends of the problem and request you to then dilate upon it. This is a question that I think will take a little bit of your time, so I'll wait on the next question until you have a chance to sink your teeth into this one. Thank you.
Yeah, actually, India is a member of the International Seabed Authority, and on behalf of India, many of us participate in the deliberations that happen in Kingston, Jamaica, at the headquarters of International Seabed Authority. The amount of time that is spent on these environmental aspects, it really surprises you. There are many invitees, many organizations like Pew Charitable Trust, the Greenpeace, so many people come as observers there. And they go through each of our document with a fine-tooth comb, and they see it with a microscope. One redeeming feature of this mining technology is that these minerals are available at a very high depths, around 5,000 meters, 2,000 meters, except for this gas hydrates. Of course, gas hydrate is it's a greenhouse gas. It's a dangerous gas. How carefully you tap it only matters. And also it can create some kind of some collapse of the sediments. It can create some kind of disturbances and all. These have to be understood. Coming to this minerals, deep sea mining, we are supposed to make an environmental impact statement first. We have to get the baseline data. First, we have to record what is the flora and fauna that is available there, and what are the currents that are available there. If we make a disturbance, how long does it take for it to really again settle back to normalcy, whether at all it settles back to normalcy. All these things we have to do it. Before we do, right now we are still in the exploratory phase. There is no code evolved for the exploitation. That is still going on for the last 3-4 years. I don't know. Maybe it will take a couple of years before it actually crystallizes. We are also a party to the negotiations. So environmental impact is actually given a very big, it is actually given a very high importance in these matters. And the area we disturb when compared to open sea, it is very small. And the density of that flora and fauna there is actually very small. Microfauna is available there. But ethically saying, okay, can you disturb a microfauna? Can you ignore it? No, we cannot ignore it. Okay, whether it will grow back immediately? No, it doesn't grow back immediately. But the disturbance caused when compared to the vast areas of the ocean, it is very minimal. and it is not in the, except in the Papua New Guinea, it is in the, their EZ, I believe, and it's very close to the shore. Here, actually, it's either it is in a Pacific or Indian Ocean. The means countries are really far away from the sites. Okay, so there is not much of disturbance or damage caused to their coasts or anything like that. That's why actually we call it a common heritage of the mankind, and the benefits that are actually going to come out of this mining will be shared with all these neighboring nations. But not that we can compensate every damage with money, but there are actually strict guidelines, penalties, and even some kind of incentives for using best technologies and creating the least damage. But I tell you, there is no mining without disturbing the environment. We have to only, there should be a balance sheet, and we have to see whether we are actually taking care of the environment, the possible extent, but there will be at least a minimum disturbance to the environment. And we have the knowledge. For the last 2 decades, we have been collecting this environmental data from Central Indian Ocean, and right now we are doing it from the Southern Indian Ocean. We have the baseline data. We are now collecting more data. We are going to put long moorings and short moorings, and we are going to study the effects of the exploratory mining. And with all this only, we will take an informed decision about going for the commercial mining. That's all I can say about that right now.
Thank you very much. That was very illuminating. Before we go to the next question, I saw that we, of course, are deeply honored once again by the presence of Commodore Rajan Veer, who is the president and emeritus of our sister organization, the Indian Maritime Foundation in Pune. So he had switched on his video briefly. I just wanted to check whether Commodore Rajan Veer, sir, do you have a question or intervention that you would like to make? Wait for a second.
Well, thank you, sir. Very happy to be attending this lecture from NIOT. I visited the NIOT about 10 years back when the remotely operated vehicle was being designed at that time, and we had a seminar in Pune where the head of the NIOT was a key speaker, keynote speaker there. So I have had contact with the NIOT in the past, and I'm very happy that I was able to attend this lecture today by Dr. Ramadass. It has brought me fairly up to date with what has been going on in NIOT. Thank you very much, sir.
Thank you so much, sir. It's always a pleasure. And one more thing, Dr. Ramadass, is that we have another sister organization of the National Maritime Foundation working out of Pune, and that is the Maritime Research Center. They specifically look at underwater maritime domain and also the acoustic habitat, underwater acoustic habitat. These are separate areas, but we would be, as I said earlier, more than keen to, to have a symbiosis running between NIOT and us. Now coming back to the specific questions, one more question from Commodore Rakesh Rana is that as you are aware, there are a number of knowledge-based organizations globally that are within this domain. And he is sure that NIOT is a member of many of these learned professional societies. And he wants to know whether you could name a few of them. And before you answer, one more point I wanted to make is that there is an umbrella engineering and maritime organization in, it's UK based. It's called IMAREST, and it too is deeply into a number of technology-based initiatives. Now, your comment that you made already about the reluctance of countries to share technologies is well noted, and yet perhaps there is some merit in sharing technology, if not as a recipient country. Maybe India should position itself as a donor country and, the provider country, if not donor. And that is what I really meant when I initially spoke about the utilization of our achievements as foreign policy tools. We are pretty poor at that, as I can understand even now. And it is an area where there is much work that will yield handsome dividends. But what he wants to really know from you is whether you could please name a few of the organizational societies, professional societies that NIOT is a member of. Before you go, sir, one more. Can I ask one more question? Which is,
yes, sir, please.
Thank you. And that is again from Aditya Sharma, who said that there was an MOU between NIOT and L&T signed recently. Could you throw some light on that agreement? Now, I think that you have already mentioned that commercial production of the 6,000 meter crawler is indeed being done by the Larsen and Toubro Defense IC, and I'm aware of that in some detail because it's an area of our own study. But if there's anything further that, perhaps Aditya missed that, or perhaps he did hear it but wants to hear something more in detail, and whichever one is applicable, and if you feel comfortable to apply or provide any further detail, I'm sure we would all be enriched. So with those two questions, let me turn it over to you again, Dr. Ramadass.
Thank you. So I'll first address the easier one. Okay, that is interacting with L&T. We signed an agreement with them for transferring the technology of our remotely operated vehicle. It's not a crawler, but a remotely operated vehicle. We have transferred the technology on non-exclusive basis. That's the only agreement, formal agreement we have with them. But we are in touch with them. See, in the Man Submersible, there is something called ballast and trim system. For taking the vehicle to 6,000 meters and bring it back, we don't use the electric propulsion because the power is limited. So we use something called ballast system, and we also use some trim system for maintaining the attitude of the vehicle. So and also we have something called a life support system for replenishing breathable oxygen and scrubbing the CO2 and maintaining the environment there for the human beings to survive. We are actually trying to come out with some global tenders or open tenders. We are in touch with L&T on that one. They are in close touch with us actually, because in the pre-bid meeting itself, where we interact with the probable bidders, potential bidders, and we exchange a lot of information about the technicalities and all. This is our interaction with L&T. And apart from this, these technologies, NIOT has also transferred some technologies about our observation systems to L&T. This is our interaction with L&T. And about the NIOT interaction with the international societies and bodies, of course, NIOT is a member of IEA, International Energy Association, especially ocean energy systems. NIOT is an active member. One of our senior scientists, she is one of the chairs of that association. And we also have close ties with the MTS, Marine Technology Society, and we are members of IEEE Ocean Humans Society actually. And we also have some MOUs with some foreign universities. We have signed an MOU with University of Washington, and then we are signing an MOU with Woods Hole Oceanographic Institute, and we are trying to sign an agreement with Scripps Oceanographic Institute and all. But the problem we have seen is some of our ex-director, Dr. Atman, is the chair of IOC Indio. But when it comes to technology, there is a problem. They want to share science with us. They can even come here and they can participate in the joint cruises and all. When it comes to technology, they are not really forthcoming. Especially, we try to, we have an agreement with the Jamstec Japan. We have an agreement with JOGMEC. And we are in touch with Ifremer, France. But they know very well that India can absorb the technology very fast. So they are actually a bit wary of sharing the technology part with us. Science, yes, they are willing to have some collaborations and all. And technology is mostly dominated by industries. Okay, so it is not entirely by this knowledge societies and all. So there is some problem in interacting with the international bodies, but within these limitations, we do have some interaction with them. But thank you for actually, I don't know whether you are hinting at, I take your hint. Okay, I don't know whether you mean it or not. Yes, there is actually, we should not work in silos. We should expand our horizons, and we have to improve our networking. As a director of the institute, I have noted this point, and we'll be widening our networks. Thank you.
Thank you very much, and that provides a perfect segue into the next question, which is that from Deep Trivedi, and he asks: is the mapping of these resources being carried out, or can it be carried out in collaboration with private consultants or private entities? Can they be harnessed under the guidance of the NIOT to collect and compile data? Because, in India, we talk a great deal at all levels of the importance of private industry and private enterprise. But when it actually comes to engaging private enterprise, both the people who talk a great deal and the private industry, both seem to develop cold feet, because private industry seems to want profits day before yesterday, and there is a lack of trust between government and private industry. So this is a naughty question, but then we could not have had a more eminent person to wrestle with it. So would you like to give it a shot?
Yeah, actually you said it really. Okay, I cannot say any better. Yes, industry should be involved. Many countries under the International Seabed Authority, aegis of International Seabed Authority, there are some contractors. They involve industry also. So a state there can be a state and there can be a contractor. Only for India and some countries, state and contractors are same. So there is a possibility of involving industry. And I think there is not only a possibility, there is a need for involving industry, because once we prove the technical viability and the technical this exploitation code is evolved, and there will be a hurry for applying for the licenses, and then it is actually not wise to look for the industry at the time. So we will be losing some time. So this is the right time for involving the industry. And in fact, our secretary, Dr. Rajivan, he advised us to start a industry sensitization workshop, or conduct an industry sensitization workshop at the earliest. Unfortunately, this COVID interfered, but again, very soon, if not on the in-person meeting, we are going to conduct two things. One is that industry sensitization for deep sea mining, and second is stakeholders and users workshop for the Man Submersible. These two meetings will be conducted. Though actually at NIOT we have very good work ethics and very good work distribution. I talk and my friends work. Okay, there are many eminent people and there are many capable scientists in NIOT who are taking care of all these things. All the takeaways from this interaction will be given to them. And as Chauhan Saab said, I am at the fag end of my career, but my colleagues, I will pass on this information to my colleagues, and definitely there will be a better interaction with the industry soon.
Thank you very much. There are no formal questions remaining here, but we do have a few minutes available to us. So with your permission, I will ask anybody from the audience if they would like to say anything or ask anything and switch on their videos one at a time. and then we will see how many of those can be absorbed. And if there are none, then of course I have one or two what I consider to be pressing questions and observations that I will then use the prerogative that I possess to ask. Rakesh, do you have another question? Yes, please go right ahead. Commodore Rana, sir.
Yeah, pardon my rig. It's not really commensurate with the event. Thank you very much for your answer. I am a fellow of this Institute of Marine Engineering Science and Technology, London, UK, and should you need to collaborate with them, I'll be really happy to facilitate that. And the other question, since I'm associated with the Foundation for Innovation and Technology Transfer of IIT Delhi, which has been incubating startups for last 28, 30 years, just wanted to know what is the encouragement you are providing to the startup community for some innovative solutions for the targets that you have set in. Incidentally, I am also PhD from IIT Madras, Department of Aerospace.
Okay.
Thank you.
That's okay. Actually, we have started one, very modestly, we have started one incubation center. We call it Magic. There is some anagram actually we have formed. And whatever technologies we are developing, we are trying to give it to some kind of entrepreneurs or some startups and all. We are in the process of setting up the procedure for encouraging the startups and giving the technology to them, even encouraging them to work in NIoT for commercializing the technologies and all. My colleague, there is one Dr. Sunakar, who is heading that cell. And if it is okay, it's agreeable to you, I will request him to get in touch with you if it is agreeable to you. Okay, so we can have a better discussion. Discussion.
Yeah. I'll share my email ID on the chat box, and anybody can contact me.
Yep.
Thank you. Thank you very much.
And I think now I understand why Vice Admiral Chauhan Saab has organized this lecture. Sir, thanks a lot. You have delivered your message to me.
One more question from Mr. Surya Narayanan, who's watching the EPL live on YouTube and is therefore asked on through our channels. His question is: has NIoT made any progress or partnered with external institutions in terms of harnessing genetic resources available on the seabed? Now, technology, of course, covers a very large ambit. And I think that your talk has been focused on certain areas. And perhaps this business of genetic engineering might lie outside the scope of the NIoT because there are other institutions. But perhaps you could just give it some broad brush input so that we can actually identify, for the sake of Mr. Surya Narayanan, which are the institutions that he might be better able to focus his query towards. Thank you.
Under the aegis of Ministry of Earth Sciences, National Institute of Oceanography, Goa is doing this work. This environmental work is being handled by them. So they are the people to interact with. Nevertheless, NIoT has one division called Marine Biotechnology Group. They are not into this work, but they can also you can talk to them also about this. I don't have much information readily available with me, but you can contact me. I can put you on to right people in the name of Goa for interacting.
Thank you very much. I think that would be perfect. We have one sort of provocative question from Nitin, and I'm a great fan of all provocative questions. I ask quite a few of them myself, as you're aware. And so his question is, okay, so why has India, and this is not NIoT specific, so he's not asking you as an NIoT director, but as an Indian, why has India not evolved a code for the private players for the exploitation and to date? That means, you know, the involvement of private industry to date, knowing very well that there will be a rush for exploitation after the exploration period. So when we do have the time, why are we frittering it away and not evolving a code? Or is there already a code, but it's just that people do not know about it?
Actually, it's uh, in NIOT, we like provocative questions because we call it Samudra Manthan. Okay, some halahal may come in the beginning, but finally we know that Amrit will come, elixir will come. Okay, so we don't have any problem in. But the problem is that there is no rush. This exploitation code is not going to come in a hurry. It is being evolved slowly, steadily. And even after that comes also, there will be a 5 years time for evolving an application with the involvement of Indian industry. Yes, it is delayed. That is because still exploration is going on, and involving industry during the exploration, it's a difficult process because we have our own government processes are there. Actually, as a director of the institute, I know well aware of the fact why these rules come into picture. It's not because of some whims and fancies of some people. These rules are in place because of some issues involved in that one. So it's not for just stopping the industry from participating in the national ventures. So this is the right time. We are going to have these interactive sessions with Indian industry. Indian industry will be brought in. We have not yet demonstrated the exploratory mining capability yet. Still, there is a room for industry participation in that one. We will make them the partners. But the first problem is that sensitization. They should know that there is a potential there. So that is what we want to tell them, that there is a possible potential and there are possible risks. So we have to tell them actually what is what. Okay, to tell them also what is available, what is not available, what role they can play, what are the risks associated with and all. We need some information to pass on to them. Right now, we believe that we have got enough information to share with the industry and to make the industry aware of and interested in participation. Otherwise, there will be a lot of questions. What has been done? What is happening? What is the seabed there? What is the abundance there? So now we have got the data. We can share it with the industry, and they can be partners. Now this is the right time, and very soon we will have a sensitization workshop, and definitely we are going to have a collaboration. I don't think we have lost any time, or there will be a mad rush after this for involving the industry. I think still we have time to salvage this. But I do agree that there is some lacuna.
We have thank you very much. We have the last 2 minutes or 2 minutes left or 3 minutes left. So we have Admiral Muralidharan, who is extremely well respected as a naval analyst and a legal expert, and he wears many hats. So I'll turn over the floor to him and ask him to make his intervention. Murali.
Yeah, thank you, Bilup, and for the opportunity. And Dr. Ramadass, very informative talk. I have only a doubt which you mentioned in passing, because I was at headquarters Western Naval Command when we were, started projecting this, that we have this 150,000 square kilometers in South Indian Ocean for exploration. Now, from what you have told us that you have done some analysis and then we have actually surrendered 75,000. My doubt is, at that time when we discussed with NIOT and their predecessors was that once we have the right technology, we'll be able to exploit the complete system. Now, have we surrendered too much back, or, that is my doubt, that when we give back 75,000, what is the kind of thing that we have?
No, actually, it is, it's a clause in the contract. You are given an area, you are supposed to survey the complete area, get the knowledge about that area, and all that information and all that, along with the some 50% of the area, we are supposed to give it back to the International Seabed Authority. For anybody, that is actually a contractual clause. Even for hydrothermal sulfides also, I think we have got 10,000 square kilometers, but some part has to be given back. The surrender is actually, it's a wrong word to be used there, but we are not surrendering it. We survey that and give it. if some developing country or underprivileged country comes in, if they want to take it, they will take that area with all the knowledge available there, because that belongs to common heritage. It's a common heritage of the mankind. That is a contribution to the international community that we are actually giving. So it is not actually, and also we choose the best area and keep with us. That is actually it's a most kept secret. Okay, so we have kept the right area with us.
Thank you very much.
Thank you. Thank you.
And in fact, the understanding of this segment of the clause or the International Seabed Authority contract is actually poorly understood. And that brings me to the last point before I turn to our chairman for his closing comments, and also to say thank you to you, Dr. Ramadass, is this, that we have an extraordinarily poor ability to actually communicate. Indian government is known for many wonderful things, but communication is not one of them. So they cannot, we hire hopeless external communicators. They communicate hopelessly. And as a result, the great achievements that we have under our belt are suboptimally made available, known not only to the external environment outside of India, which is crucial for developing the kind of image that Indian science needs to develop. More than science, applied engineering being technology, it is technology. And so India has an image of only being a supplicant for technology. You know, cross-legged, you are sitting there with PL 480 bowl and requesting somebody give us something. Whereas the truth is very far away from this image. And it is very important for us, for NIOT, for organizations like the National Maritime Foundation itself, to be able to join hands and do these road shows, whether they are internal to India, they are university-based, they are academia-based, they are think tank-based, they are MEA and diplomacy-based, or they are external to India altogether. This is something that we have done with remarkable incompetence. Remarkable. For a country that produces so many ads, so many movies, the inability to generate image is actually quite surprising. So this is my last point here and comment is, it really doesn't require a response from you because I will pursue you after this. And that is that, this is for everybody. And this should be the NIOT, and it is in fact the NIOT motto, which says that he who says it cannot be done should never interrupt he who is doing it. And so, sir, you please bash on regardless and make sure that the country develops into a country, as you correctly put it, that is worth defending, that is worth fighting for. And that is the great contribution that NIOT and organizations such as NIOT and leaders and needles of excellence such as yourself have to offer. And this is no small contribution indeed. So let me once again say thank you to you on behalf of all our members of the audience, all of whom I'm sure have been as enthralled by your talk as have I. And now with a sense of humility and gratitude and honor, let me request our chairman, Admiral Sunil Lamba, former chief of the naval staff of the Indian Navy, to please give his concluding remarks. Over to you, Admiral.
Thank you, Admiral Chauhan. Dr. Ramadass, Admiral Chauhan, ladies and gentlemen, a very good afternoon to you. At the outset, on behalf of all of us, I'd like to thank Dr. Ramadass for a fascinating talk on what is happening, what is being done by NIOT and him in the environment of the ocean. We're fortunate that this lecture has taken place on the 11th of May, today also being the National Technology Day. And on 11th of May in 1998, we also successfully test-fired the Shakti-1 nuclear missile at the Pokhran test range. So 11th of May is an important day in our calendar. The ocean is the new frontier, and exploration of the ocean bed at whatever depth is the cutting edge and the new frontier in the future. A lot of questions were raised on the commercial viability of what is there on the ocean bed. The mute point is wherever research is taking place of whether it's gas hydrates or deep sea mining or research on the ocean bed at depths beyond this thing, most of this is being funded by governments and being done by agencies, whether it is even the private sector involvement. The funding of this research and development is by Government of India. Okay. And that is what is going to be the way ahead. Private sector and industry is only going to come in at a later stage when there is a commercial necessity and viability to mine these minerals from the depths of the ocean, when we run out of resources on land. So this is going to be continuing. NIOT is going to be the spearhead of this. And I entirely agree with what Dr. Ramadass said. There are government procedures and processes which need to be followed. They have their own impediments with audits, test audits, procedures, which he and I know very well how they stymie progress. He made a mention on sharing of technologies. No company, no government shares technologies on a platter. If you need a particular technology, we'll have to develop it ourselves. And this is very clear in the field of defense also, whether you're talking about defense equipment. Nobody gives you cutting edge technology, even if you're willing to pay for it. Okay, so this, we have made remarkable progress, which came out loud and clear in his presentation of what we have achieved in the time frame which we have done. And we are there with the rest of the world and even ahead in a certain field of development. And for this, I must congratulate Dr. Ramadass and NIOT to taking India where it is today in the field of deep sea mining and research in all the fields. Like you take space and you see what is happening in space today. Earlier, it was the preserve of government organizations, whether in India it is ISRO, they have their partners in the form of private sectors. When you take the United States, you had NASA, and now you have a whole lot of different ventures taking place, like Elon Musk, whether it's Jeff Bezos and his company, which are now into space. I am sure as time progresses, this is going to happen in the undersea segment also. When there is a necessity and commercial need to mine nodules or look at gas hydrates, you will find private sector also coming in. The point which Admiral Chauhan made of sending the message across, collaboration between NMF and NIOT to share knowledge base, I think it's a very important factor. I mean, the two organizations which look at the marine environment and the marine sector need to work together. One is to put out the message of what we are doing and what is happening in this field, because it's been an eye-opener to a lot of us of what NIOT has achieved in the last couple of decades. And I think we need to work together to take this message across, not only within the government, but also to the country at large and overseas. In the end, on behalf of all of us, I'd like to thank Dr. Ramadass once again for his illuminating talk. And on behalf of us, we'd like to pay our compliments to you. Thank you.
Thank you very much. And now may I request everybody once again to please switch on your cameras while leaving your microphones off so that we can get some wonderful pictures, because I think that this has been a spectacularly successful talk, and it would only be fitting for us to be able to publicize this as much as possible, and we need all your charming faces to be available as proof positive for the fact that we did this. So Supriya, please take your shots while the cameras are all switched on. Thank you so much. Supriya, please do come up on mic and tell us when you're done. It will take a few minutes because we have to shift screens, but Supriya will inform us in a minute or thereabouts. Supriya, are you listening?
With the permission of the chair, I would like to say something.
Oh, yes, of course.
This is called eminent persons talk, but for me, this is talking to the eminent persons really. And with all humility, I have learnt a lot. There are many takeaways. Now only I understand the reason and purpose of this talk. Thank you very much, sir.
You do us too much honor. First of all, you do us honor by your presence and then by the graciousness of your comments. Thank you very much indeed. And Supriya, if you're done, can we get an input from you? Right. We have pretty much everybody available. So they're last minute glitch solvers and they have solved their particular glitches, and the mic, the cameras can, the videos can indeed be put on once again. We would be delighted. Otherwise, we're going to go down to a count of maybe 5, and then we will call it a day. So 5. This is a good time for Gargi and Dr. Chaudhary. Yeah, great. Thank you. 4, 3, 2, last chance, big smiles, 1. All right. Thank you very, very much, everybody, ladies, gentlemen, Dr. Ramadass, Admiral Lamba, eminences, flag officers, senior officers, scientists, eminent personalities. Thank you so very much. It's been a sheer pleasure to have had Dr. Ramadass with us, and thank you so much for being part of the NMF process of eminent persons lectures. And notwithstanding whatever Dr. Ramadass said at the end, we know where the true eminence is, and it's very much on his shoulders. So thank you once again. Goodbye, and have a great balance of the day.
Okay, Dr. Ramadass, stay safe, all of you.
Thank you, sir.
Thanks, Sunil.
Bye.